after studying this module, you shall be able to know what is petroleum product, how the petroleum or the crude oil forms in the nature, what are the physiochemical properties of petroleum, what is a flashpoint, and what is the process of fractional distillation. All this is very important when we are studying forensic science. So, keeping in mind that at the crime scene the petroleum products are very commonly found, we will be studying about all these things. Petroleum is a chain of aromatic and aliphatic hydrocarbons, and hydrocarbons, you must be already familiar, are the organic compounds basically contained of carbon and hydrogen. Although in the aromatic hydrocarbons you have the benzene and the naphthalene, these type of rings, and there are other extra elements like nitrogen, sulfur, halogens also present in these compounds, and it is basically a mixture of all these compounds which is found in petroleum. Petroleum, which is also called as crude oil, varies dramatically in color, odor and the other flow properties which reflect the diversity of its origin. Petroleum products are any petroleum based products that can be obtained by refining and comprise of various products like refinery gas, the ethane, liquefied petroleum gas which is called as LPG, naphtha, gasoline, aviation fuel, marine fuel, kerosene, diesel fuel, distillate fuel oil, residual fuel oil, gas oil, lubricants, white oil, grease, wax, asphalt as well as coke. So, all these are later on separated from this petroleum, and when petroleum, which is the crude oil formed and available in nature, is actually a mixture of all these products or compounds. The four fractional types into which petroleum is subdivided broadly are paraffins, olefins, naphthenes and aromatics. That is, this is often abbreviated as PONA. P standing for paraffin, O standing for olefin, N standing for naphthlenes and A representing the aromatics. Paraffinic hydrocarbons include both normal and branched alkenes, whereas olefins refer to the normal and branched alkenes, that is, they have double bonds in them and even triple bonds. So, these are the carbon-carbon double or triple bond containing molecules. On the other hand, the naphthenes, mind it is not to be confused with naphthalene. Naphthene is a term specific to the petroleum industry that refers to the saturated cyclic hydrocarbons. And finally, coming to the fourth point, that is the term aromatic, it includes all hydrocarbons containing one or more rings of the benzenoid structure, that is, benzene type of rings are there, whether they have one or two or more than that. So, after knowing about this PONA, let us move further. The terms light and heavy or sweet and sour provide convenient terms for use in descriptions. For example, light petroleum is often referred to as conventional petroleum, is usually rich in low boiling constituents and waxy molecules, whereas heavy petroleum, it contains greater proportion of the higher boiling, that is, they have high boiling points, they are more aromatic and they have heteroatoms like nitrogen, oxygen, sulfur and sometimes even metal containing constituents. Heavy oil is more viscous than the conventional petroleum and requires enhanced methods for recovery. Bitumen is near solid or solid and cannot be recovered by enhanced oil recovery methods. Coming to the conventional or the light petroleum oil, it is composed of hydrocarbons together with smaller amounts of organic compounds of nitrogen, oxygen and sulfur, and still smaller amounts of compounds containing metallic constituents, particularly vanadium, nickel, iron and copper. The processes by which petroleum was formed dictate that petroleum composition will vary and be site specific, thus leading to a wide variety of compositional differences. The term site specific is intended to convey that petroleum composition will be dependent on regional and local variations in the proportion of the various precursors that went into the formation of petroleum, as well as variations in temperature and pressure to which the precursors were subjected. Thus, the purely hydrocarbon content may be higher than 90% by weight for paraffinic petroleum, and it may be 50% by weight for heavy crude oil and much lower for tar and bitumen. The non-hydrocarbon constituents are usually concentrated in the higher boiling proportion of the crude oil. So, after knowing about this basic about the petroleum, let us study more in depth about the flashpoints and how the petroleum fractionation is done to get the various fractions. Dear students, in the study of forensic chemistry, it is very important to study about the petroleum oil and various petroleum products which may be found at the crime scene, especially crimes involving fire. Petroleum oil is a fossil fuel and it is often also called as crude oil or rudimentary oil. The petroleum products, as the name suggests, are the products obtained from petroleum, that is this crude oil, and these petroleum products are useful materials derived from the petroleum oil after its processing in oil refineries. Petroleum products are nothing but complex mixture of various chemical compounds. The majority of petroleum oil is converted to petroleum products, which includes several classes of fuels, the gasoline, kerosene, fuel oil and lubricating oil. Let us understand how crude petroleum and natural gas were formed. They were formed almost 300 to 400 million years ago. The sea plants and animals died and were buried on the ocean floor, that is the bed of the ocean, and over time they were covered by layers of various rocks and rudiments and sediments. In the course of around million years, decayed plant and animal remains have remained buried under the thick layers of rock. The enormous heat and pressure turned them into oil and gas. In the course of around million years, decayed plants and animal remains, they have remained buried, and under these thick layers of rock, they have gone into various transformation. If we go into the detail of how and what is there inside the petroleum is a mixture of many substances. These substances are mainly composed of carbon and hydrogen and are therefore called as hydrocarbons. Other elements such as oxygen, sulfur and nitrogen may also be present in relatively smaller quantities, together with traces of phosphorus and heavy metals like vanadium and nickel. The exact molecular composition varies widely from the formation to formation, but the proportion of chemical element varies over very narrow limits. Now, what you can see here is carbon, the percentage is shown for all of these, and what you can see is the carbon is around 83 to 87%, hydrogen is 10 to 14% in the chemical composition, nitrogen is 0.1 to 2%, you can see it is in quite less amount. Similarly, the oxygen is in less amount, it is 0.05 to 1.5%. Sulfur is also in very negligible amounts, it is 0.05 to 6%, and the other minerals or elements are even less than 0.1%. So, what you Now know is that about the chemical composition of petroleum, it is mainly the carbon and hydrogen compounds, and with rest other elements like nitrogen, oxygen, sulfur and etc. After knowing about the element composition, if we try to know what are the type of molecules, the petroleum products contain mixture of these hydrocarbons, that is the compounds containing carbon and hydrogen, and there are four type of molecules of hydrocarbons which are mainly present in the petroleum products. They are parabens, as you can see the structure shown here, naphthalene, aromatics and aliphatic, whose structure are shown here. They are in general representation, we will see, because they are the class of compound, and you can have the number of carbons varying in them, but in general you will find that naphthenes have these type of cycloalkane type of compounds, the aromatics have the benzene type of structure, either one or two, or then parabens are aliphatic compounds of carbon hydrogen in a long chain manner. Okay. So, that is how we are having these four as the main type of molecules of hydrocarbons which are present in the petroleum various products. Let us now learn about the fractional distillation, which is the primary method through which the crude petroleum is separated into its different components on the basis of their different boiling point. That is, the differential boiling point will help us separate some molecules which have low boiling points will be coming out first, the ones which are having next higher boiling points will be coming next, and the compounds which have even more higher boiling points will be coming later. So, that is how the differential boiling point is the basis for separation of the petroleum mixture into different products, and the different components which are obtained, the different products which are obtained, they are called as fractions. So, you can see here in this diagram the fractional distillation of crude oil. Crude oil is very dirty, black, almost blackish in color, and when this is subjected to fractional distillation, you can see the different fractions, the very small amount shown here, and they have different colors in them. So, you can see here very light color, this will be the lowest boiling one, and then similarly as you go towards the higher one, then they will have a darker and darker color also. So, color wise also it is important to notice from forensic science point of view that what type of product is present at the crime scene. Now, let us learn about the fractional distillation of petroleum in detail. The primary process for separating the hydrocarbon components of crude oil is fractional distillation. The fractional distillation differs from distillation only in that it separates a mixture into a number of different parts, that is, which are called as fractions, and this is done on the basis of different boiling points. The substances having lowest boiling point are thus which have least number of carbon atoms in them, and they come out first, followed by the ones which have more or higher number of carbon atoms. So, they will be having higher boiling points. The major fractions which are obtained through this process, and what is this process? Let me repeat. You are subjecting a mixture into this distillation tower, and as the heat is provided, all this mixture is getting separated on the basis of different boiling points. The compounds which have less number of carbons will be travelling in this tower on the top because they are lighter and they will get heated up first, and in their vapor form they travel on the top of the tower, and at that very particular lower temperature that fraction will be coming out which will have the lowest boiling point. After that, the molecules which are having next higher boiling point will be coming, they will be coming comparatively from the lower position, and then the next and the next. And what happens is, all this is happening simultaneously, because taking out the output from different levels, we are also ensuring that at the top level the compounds having lowest boiling point will be coming out, and at the bottommost level the compounds which have highest boiling point, they will be coming out. So, there is a gradual increase in the boiling point of the fractions that we are getting as we move from the top to the bottom of this tower. The major fractions which are obtained through this fractional distillation of crude petroleum are refinery gases, petrol, naphtha, kerosene, diesel oil, leaving behind a residue at the last fraction, and out of these you can see the refinery gases are coming on the top. They are gases having the lowest boiling point, and then as we go to the bottom side of this fractionating column, we have petrol, then naphtha, and at the lowest we have the residue which is there. The fraction obtained still contain mixture of substances and are further treated to convert them into the mixture of more useful saleable products by various methods such as cracking, reforming, alkylation, polymerization and isomerization. So, what I said I mean is just now we have seen the fractional distillation where broad fractions are being obtained, but these broad fractions still contain many compounds in them, and it is important to further separate these compounds and sometimes even interconvert them into much more desirable products which are more useful to the mankind in the form of saleable products. So, that is what is done by subjecting these fractions into cracking, reforming, alkylation, polymerization and isomerization. These mixtures of new compounds are then separated using methods such as fractionation and solvent extraction. Impurities are removed by various methods, for example dehydration, desalting, sulfur remover and hydrotreating. So, all these treatments will be helping us to make them separated into pure components, the pure compounds, which will be more beneficial. As a forensic scientist, you should also be familiar about the various properties of the petroleum which are used as standards for knowing their quality. And these standards, the very common one are the octane number and the cetane number. So, the quality determination is done by octane number and cetane number. What is meant by octane number? Octane number is a standard measure of the performance of a motor or aviation fuel like gasoline or petrol. The octane rating is measured in a test engine and is defined by comparison with a mixture of isooctane and heptane that would have the same anti-knocking capacity as the fuel under test. The percentage by volume of isooctane in that mixture is the octane number of the fuel. Coming to the next point, which is the cetane number in determination of the quality. Cetane number is the measurement of the combustion quality of diesel fuel. Thus, it is approximately equivalent to octane rating for gasoline. So, cetane number is used for diesel and the octane rating is used for gasoline or petrol. The higher the octane number, the fuels have higher performance in petrol engines, and in contrast fuels with lower octane number and higher cetane number are ideal for diesel engines, and the use of gasoline with lower octane number may lead to the problem of engine knocking. So, that is why in some anti-knocking compounds are added, but then the anti-knocking compounds are also they are poisonous because they contain mostly lead and they are not so environmental friendly. So, now what you find in the market, the fuels that you use are devoid of the lead, that is they do not have such anti-knocking compounds because they are environmental dangerous and you can say they are not environmental friendly. Another property associated with volatile petroleum is its flash point. The flash point is defined as the lowest temperature at which it can vaporize to form an ignitable mixture in air, that is the mixture which will catch fire. And for measuring the flash point, an ignition source is required, and very commonly used apparatus is the Abel's apparatus. So, the Abel's apparatus is used for measuring the flash point, and at the flash point what happens is the vapor may cease to burn when the source of ignition is removed. So, as you can see here, these are the flash points of some common fuels which are shown here, and in this table notice that the gasoline or petrol are most volatile and they have the lowest flash point. So, those petroleum products which have the lowest flash points will catch fire very instantaneously, and those which have higher flash points, they will catch fire slightly at a lower pace. So, after knowing about the flash point, when it is higher it will take less time, and it is very important when you have the crime scene having fires, that what type of fuel has been used, whether the fuel had a low flash point or the high flash point, and that will also give you the idea what type of fuel, whether it is petroleum or the diesel or any other which was used to burn that crime scene. Coming further, let us talk about reforming. Reforming is a process which uses heat, pressure and a catalyst, usually containing platinum, to bring about chemical reaction which upgrades naphthas into high octane petrol and petroleum feedstock. So, as we have learned, the various processes are used on these fractions to convert them into more useful, and the more useful out of naphtha and the petrol is obviously petrol. So, what we do in reforming is, with the help of heat, pressure and catalyst, the naphthas are converted into high octane petrol and petrochemical feedstock. After studying about reforming, let us be familiar about the cracking process also. In the cracking process, the breakdown of heavier hydrocarbon molecules, that is having high boiling point, into lighter products, that is having low boiling points such as petrol and diesel, takes place. And these processes include, first, the catalytic cracking which takes place in the presence of catalyst, thermal cracking which takes place in the presence of heat, or it can be hydrocracking which takes place in the presence of hydrogen gas. So, what we understand is, in the cracking process, the bigger molecules are broken into smaller molecules which can be done with the help of catalyst or heat or hydrogen gas. Next is the isomerization reaction. Now, you must be already aware, isomers are the compounds which have same molecular formula, but they have different structures, or 3D in stereo. Here we will be referring to the change in structure. So, the isomerization reaction, which refers in case of the petroleum products being converted into other, it refers to the chemical rearrangement of the straight chain hydrocarbons or paraffins into more branched ones, and these branched ones are actually the isomers of what we are starting with, but they have the same number of carbon atoms. And as an example, you can see, as it is shown here, the normal pentane, which is commonly called as pentane, when it is subjected to isomerization, gets converted into isopentane and neopentane. After isomerization, let us see how the polymerization also helps to transform one petroleum product into more useful products. Poly means many, and in polymerization, many light unsaturated hydrocarbon molecules, they combine in the presence of catalyst and pressure and temperature conditions to form large hydrocarbon molecules, that is, mostly it is the chain of hydrocarbon molecules which is formed. For example, when you start with styrene and you subject it to polymerization, it gets transformed into polystyrene. The so obtained gasoline is often referred as polymer gasoline. So, such process is often used to react butenes, that is olefin molecules with 4 carbon atoms, with isobutane, which is branched paraffin molecule with 4 carbon atoms, and this way it gives the high octane olefinic petrol, which has the blending component. This is called, which is used as the petrol blending component, and this is called as polymer gasoline, and the structure of polymer gasoline is shown here. Let us now become familiar with the hydrotreating method. It is one of the way to remove many of the contaminants from many of the intermediate or final petroleum products, and in the hydrotreating process the entering feedstock is mixed with hydrogen and it is heated to the range of 300 to 380 degrees centigrade. The oil combined with the hydrogen then enters in a reactor, as you can see here, and which is loaded with a catalyst, and this catalyst promotes several reactions happening inside. For example, the hydrogen can combine with sulfur and it can form the hydrogen sulfide, and hydrogen sulfide being gas, it will be removed as a gas. So, the sulfur contaminants, they get removed and you will get desulfurized diesel from the impure diesel. So, hydrotreating is a way where the compound or the mixture which is not having purity, and the impurities like sulfur and other elements, if you want to remove, that is subjected to hydrogen and subjected to heat, and in the presence of catalyst there are various byproducts as gases form which escape out, and from the separator you can see you get the corresponding pure compound, the pure petroleum product, for example the desulfurized diesel as shown in here. So, after studying about what is petroleum or the crude oil and how the fractional distillation helps us separate the various components of this crude oil into so many useful products through the petroleum fractionation or the fractional distillation, and then studying about some aspects like how reforming or isomerization or cracking can do the interconversion from less useful petroleum products into more useful saleable products, we have studied. Let us be familiar about the various fractions and their commercial uses. So, the petroleum products which are refined from the liquid fractions of crude oil, they can be placed into 10 main categories, and these main products are further refined to create materials which are more common to everyday life. The 10 main products of petroleum or crude oil are as follows. They are first asphalt, then diesel, fuel oil, gasoline, kerosene, LPG or the liquefied petroleum gas, lubricating oil, paraffin wax, bitumen and petrochemicals. And if we try to know where are the commercial uses for this, because this is very important from forensic science point of view, because when you are at crime scene, you what type of products and for what use they are being used, you should be able to know that yes, this is the starting molecule or the petroleum product where it is coming from. So, coming to asphalt, asphalt is commonly used to make roads. It is a colloid of asphaltenes and maltenes that is separated from other components of crude oil by fractional distillation, and once asphalt is collected, it is processed in a de-asphalting unit and then goes through a process called as blowing, where it is reacted with oxygen, and with oxygen it gets hardened, and the moment it gets hardened it can be used to make roads. Asphalt is usually stored and transported at around 300 degrees Fahrenheit. Coming to diesel, diesel as again is very you are commonly familiar. Diesel is any fuel that can be used in a diesel engine, and diesel is produced by fractional distillation between 392 degrees Fahrenheit and 662 degrees Fahrenheit. Diesel has a higher density than gasoline and is simpler to refine from the crude oil. It is most commonly used in transportation. Fuel oil. Fuel oil is any liquid petroleum product that is burned in a furnace to generate heat. Fuel oil is also the heaviest commercial fuel that is produced from crude oil. The 6 classes of fuel oil are distillate oil, diesel, that is the distilled fuel oil, diesel fuel oil, light fuel oil, gas oil, residual fuel oil, heavy fuel oil. The residual fuel oil and heavy fuel oil are known commonly as Navy special fuel oil and bunker fuel because they are used in Navy and bunker fuel. Both of these are often called as furnace fuel oil also. Gasoline, if you look at the details of gasoline and where it is used, almost half of the crude oil refined in United States is made into gasoline. It is mainly used as a fuel in internal combustion engines like the engines in car. Gasoline is a mixture of paraffins, naphthenes and olefins, although the specific ratios in these parts depend upon the refinery where the crude oil is processed. Gasoline refined beyond fractional distillation is often enhanced with iso-octane and ethanol so that it is usable in car. Gasoline is called different things in different parts of the world. Some of these names are like in India we are more familiar with petrol, somewhere we use the petroleum spirit, somewhere it is called as gas or petrogasoline and even mogas. Coming to the next important, kerosene. Kerosene is collected through fractional distillation at temperatures between 302 degrees Fahrenheit and 527 degrees Fahrenheit. It is combustible liquid that is thin and clear. Kerosene is most commonly used as jet fuel oil when it is very refined quality and as heating fuel in gas stoves and all. So, coming to the next is the LPG, which is liquefied petroleum gas. Liquefied petroleum gas is a mixture of gases that are most often used in heating appliances, aerosol propellants and refrigerants also. Different kinds of LPGs are propane and butane, and mostly it is the mixture of these two. In normal atmospheric pressure, liquefied petroleum gas will evaporate. So, it needs to be contained in pressurized steel bodies, and that is why the name it is liquefied petroleum gas. It is the gas which has been liquefied. Next is the lubricating oil. Lubricating oil consists of base oils and additives. Mineral oils are manufactured by special processes called solvent extraction, catalytic dewaxing, hydrocracking and isohydromerization. Different lubricating oils are classified as paraffinic, naphthenic or aromatic. Lubricating oils are used between two surfaces to reduce friction and wear. The most commonly known lubricating oil is motor oil, which protects moving parts such as internal combustion engine, and this is again used inside the car engine and even various motors. Coming to paraffin wax. Paraffin wax is a white, odorless, tasteless, waxy solid at room temperature. The melting point of paraffin wax is between 117 degrees Fahrenheit and 147 degrees Fahrenheit, depending on other factors. It is an excellent electrical insulator, second only to Teflon, a specialized product of petroleum. Paraffin wax is used in drywall to insulate buildings. Coming to bitumen, bitumen commonly known as tar is a thick black sticky material. Refined bitumen is the bottom fraction of the fractional distillation of crude oil, and this means that the boiling point of bitumen is very high, so it does not rise in the distillation chamber at all. The boiling point of bitumen is 977 degrees Fahrenheit. Bitumen is used in paving roads and waterproofing roofs and boats. Bitumen is also made into thin plates and used to soundproof dishwashers and other hard drives in computers. Petrochemicals is actually a very broad term, and petrochemicals are the chemical products which are made from the raw material of petroleum. These chemicals, they include ethylene, which is further used to make anesthetics or antifreeze and detergents. It can be propylene, which is used to produce acetone and phenol. It can be benzene, which is used to make other chemicals and explosive. Toluene, which is used as a solvent and in refined gasoline, and again from toluene we can prepare so many other synthetic organic compounds. And xylene, which is used as a solvent and cleaning agent. So basically petrochemicals are the various chemical compounds which are synthesized by taking the petroleum products as the raw materials, and this we have listed is only very less. Millions of petrochemical compounds can be formed, because even from these 4-5 which we have named, so many transformations through the organic synthetic chemistry can be done to convert them into various other compounds. Let us summarize what we have learned in this module. We have learned that petroleum is a fossil fuel, often called as crude oil or rudimentary oil. The 4 different types of hydrocarbon molecules appear in crude oil. They are paraffins, naphthenes, aromatics and asphalts. Petroleum products comprise of the various characteristics for identification and their quality, and they are like density, coefficient, viscosity, vapor pressure, boiling point, so on. But out of these we have studied in this module, the detail is the octane number, the cetane number and the flashpoint. The primary process for separating the hydrocarbon components of crude oil is fractional distillation. In addition, what we have studied is that the petroleum refining processes are the chemical processes, and other facilities used in petroleum refineries to transform the crude oil into useful products are the reformation, the catalytic, the cracking, the alkylation, the polymerization, isomerization. So these are also very important to convert from one form to other, and the other which we are converting is more saleable compound or product. And these mixtures of new compounds are then separated using methods such as fractionation and solvent extraction, and further impurities are removed by various methods like dehydration, desalting, sulfur removal and hydrotreating.